In this video, we are going to talk about independent events and how some events can have an influence on what happens next, and then some of them don't. So here are three different examples, and we'll have a look to see whether these are independent events or not. So the first example is choosing a mug each day of the week. So you might go in the morning, make yourself a hot chocolate before you get up and go. And the first day you might randomly close your eyes, reach into the cupboard, and you might randomly choose a mug. And the first day you might draw out the red mug. So then you have your hot chocolate, you clean it because you always do that straight afterwards. You put it back in the cupboard and then you head off to school or work. The second day you might do the same thing. Close your eyes, reach into the cupboard, draw out one of the mugs, and you might draw out a red one again, just by chance. So the chance of drawing out a red, blue, or black mug is the same every single day, because every single day there are three different colours with equally likely chances of happening. So this one we would say that each day choosing a mug, we'd say that that is an independent event. Give it a big tick. Okay, our second example is flipping a coin. Now, remembering that coins have two sides, a head and a tail. So that's my attempt at trying to draw a cow and its tail to show tails. So you might flip a coin once and it lands on the head side, and then you might flip a coin again and it lands on the tail, and then flip it again, it lands on the tail. So in this example, it doesn't matter what happened before, because each time you flip that coin, the chance of flipping either a head or a tail is going to be exactly the same. They don't have an influence on each other. So we'll also say that these events are independent. Give this one a big tick as well. Now, our last example. So we have two friends that are going to make a hot chocolate, and they're both going to randomly take a mug out of the cupboard. So the first friend will go in, they'll close their eyes, reach into the cupboard, draw out one of the mugs, and they'll take out a blue one. So they'll take out a blue mug. So now there's actually only two left. Now the second friend will go in and they'll reach into the cupboard, and rather than a 1 in 3 chance of getting, just say, a red mug, now it's actually a 1 in 2, because the total number of mug options have changed. And also, one of the options isn't even there anymore. There are no blue ones. So this is what we would call dependent events, or not independent. So it just means that whatever happened in the first trial will definitely have an impact on the second trial. So that first friend that drew out the blue mug, well, depending on what colour that person chooses first, it's going to definitely have an impact on the second person, because if the first friend takes out that blue mug, it's impossible for the second friend to also draw out a blue mug. So we would say that these are not independent. Not. Big cross next to that one. So now let's quickly have a look at how these probabilities can change by calculating some of these for independent and not independent events. So first of all, let's have a look at the independent event. So choosing a mug each day, but you put it back before you take out your next mug. So what's the probability that the first mug is blue? Okay, so that's an easy one. That's going to be 1 out of 3. So there's always 3 options in total, and only one of them is the favourable option. Only one of them is blue. Awesome. Now, the second option, what's the probability that the second mug is going to be red if the first one was blue? So this is like picking a blue one on Monday, picking a red one on Tuesday. So we're looking for what is the probability that on Tuesday it's going to be red, even though the day before came out blue. Well, because you put the mug back in every time, it doesn't matter. It's still going to be a 1 out of 3 chance. So still 1 out of 3 chance that the mug will be red for the second step of this experiment. Now, this is where it gets a little bit different, because these events, so two friends choosing a mug on the same day, or one after the other, these ones are not independent. We've already figured that out, but let's calculate the probability to see how they differ to what we had above. So again, what's the probability that the first friend takes out a blue mug? Well, That's 1 out of 3. There's still a 1 in 3 chance that the first person draws out a blue mug. Okay, now this is the second person now. What's the probability that this person takes out a red mug, considering the first person took out a blue mug? Well, we need to think about what are the total number of outcomes. So if the first person drew out a blue mug, that means that that option's gone. So that means that the total number of outcomes is now 2. And how many of those are favourable? Well, only one of them is red, so it's a 1 out of 2 chance. So you can see that for an independent event, the probability will remain 1/3 all the way through, even if you have, 10 days that you're taking mugs. Doesn't matter how far you go, the probability will keep being the same each time. But for events that aren't independent, the first event, that was 1/3. Second event, well, the total number of outcomes changed down the bottom of the fraction, and sometimes the number of favourable options can change as well. So the probability will be different for the second step, the third step, and the fourth step.